Algebra 2, Common Core, long division. So polynomial long division is probably one of the more difficult things that we have in this course, and you're doing it like day 3. It's not that any piece of it or any individual step is difficult. There's just a lot of steps to it. It is a long problem, pun intended. And so there's going to be several steps of multiplying, division, distribution, combining like terms, things like that. And so if you make a mistake somewhere in the process, you get the wrong answer in the end. So you have to be very careful with your algebra operations here. Now, to help remember the procedure here, I use 4 letters. DDCC. And what that stands for is divide, distribute, change, combine. Divide, distribute, change, combine. And I'll talk about each of these individually. So the first step we do is the division step. So first we divide. And what that really means when we divide is you don't want to look at this whole long chain divided by this piece here. Now first of all, a little bit of terminology. This is called the divisor. This is called the dividend. And the answer we get is called the quotient. So the divisor, dividend, and quotient. But so I'll use those terminologies just so you know. But when I do the division step for the first time, I only look at the front. Divide front by front. Front by front. So the front of this divided by the front of this. That's all I'm looking at. So 3x cubed divided by x. If you need to do a little bit of algebra, scrap work off to the side, you can. And so 3x cubed divided by x is 3x squared. And I put the 3x squared here. The reason I put it here is because everything is going to be lined up in columns. Anything with an exponent of 3 is going to be lined up over here. Anything with an exponent of 2 is lined up over here. Exponent of 1, and all the constants will be on the end. So that's first thing you need to know right there is you need to have everything lined up properly to keep the order and the structure. So 3x cubed divided by x is 3x squared. You could also kind of think reverse multiplication. This times what is this? Well, times 3x squared type stuff. But it's just division. Monomial divided by monomial. 3x cubed divided by x is 3x squared. That's division. That's the first step. The second step is to distribute. And what I mean by that is we have to distribute the 3x squared to everything in the divisor. So we distribute 3x squared to x minus 5, and we write it down here. So 3x squared times x is 3x cubed. And 3x squared times negative 5 is negative 15x squared. Now it's important that if you are correct so far, these should be exactly the same right now. That's the purpose of the division, is to get these to match. So if these don't match after distribution, something is wrong. All right, so we divided the front by the front. We distribute it to the divisor. Then step 3 is we change. And what I mean by that is we're going to subtract this minus this. And by subtracting this whole thing down here, the good way to do that is to just think change the signs. So make that negative, make that positive. Change the signs of what you got from the distribution. So these no longer are exactly the same. They are additive inverses. So I divide to get this. I distributed it to get what I had in red. Then I changed its signs. And then the last step was to combine. I combine these things, and in that process, these cancel out because I divided and distributed to get an exact copy of it, but then when I change the signs, they're additive inverses, so these cancel out, and that should always happen. If that first piece does not cancel out, something's wrong. These may or may not cancel out. Negative 13x squared, positive 15x squared. Now, they should all be like terms because they're lined up together. The answer is 2x squared when I combine a negative 13 and a positive 15. That's one round of long division. So we divided to get this, we distributed to get the red, we changed the signs, we combined to get this. Now we bring everything down, and we repeat the process. We go back to the first D. We divide, then distribute, then change, then combine. But now that we're back to the first step, we're now looking at this polynomial divided by this. And again, for the division, it's still just the front divided by the front. And so 2x squared divided by x is 2x. Then I distribute it to the entire divisor to get 2x squared, and 2x times negative 5 is negative 10x. I change the signs. These cancel out as they should. These do not, to get me negative x, or negative 1x. Bring down the next piece, plus 5. You notice that when your divisor is a binomial, you'll be working in binomials things. Because when you distribute, you get a binomial. So I'll be combining binomials, and then you keep dragging things down until, lastly, all that's left is a binomial divided by a binomial. But so for that last step, again, I divided 2x squared by x to get 2x. I distributed the 2x to both xn minus 5 to get what I had in red. Then I changed the signs, and then I combined these two together. Just the first one cancels out. This gives me just negative x. That's a second round of long division. Back to the front. I divide. So after we change, we go back to the front. I divide negative x by x. And negative x by x is negative 1. I distribute that negative 1 to both of these pieces, negative x plus 5. I change the signs and combine. That cancels, remainder is 0. Now, you won't always have a remainder of 0, and we'll talk about what to do if you do have a remainder. But for now, let's just say, all right, when it's a remainder of 0, that means you probably did the question right. But you will sometimes have remainders, so we can't rely on that. But this is how we do it. Divide, distribute, change, and combine, and then repeat. And what we could do to check our answer, if we really wanted to, was the quotient that we got, the 3x squared plus 2x minus 1. That, if we multiply that by the divisor, we should get back to equaling the dividend 3x cubed minus 13x squared minus 11x plus 5. Now that's a decent amount of work in itself, so I'm not going to show that here, but if you happen to finish a test early kind of thing and you want to check your work, that's one way to do it. Let me do one more example for you. All right, now here's a multiple choice question. So we're going to have to do this work. Maybe I'll rewrite this problem over on the side, but one thing to look for, and I'll talk about what to happen in class, that notice my exponents go 4, 3, 2, that's an exponent of 1, and then no exponent. It's important that you have that all there. Like, say I was missing this piece. It went 4, 3, 1. You kind of want to take note of that, you know, and we're going to talk about that in class, but just have that in the back of your mind right now. All right, so if we were to do this work, let me say I'm going to rewrite this over here so I can do the work underneath it. And then we got 2x to the 4th plus 21x cubed plus 35x squared minus 37x and plus 46. Oh, I'm running out of room. Plus 46. Sorry, super sloppy. Hopefully you're writing neater. Don't forget, if you ever need to pause the video, write some stuff, catch up. If you need to rewind a little bit, go ahead. Divide the front by the front. 2x to the 4th divided by 2x is simply x cubed. Distribute that to both. I get 2x to the 4th plus 7x cubed. All right, that's 2x to the 4th, 7x cubed. Change some signs. These cancel out. I got 21 minus 7 is 14x cubed. And I'm just going to bring down the plus 35x squared. You could bring down every piece every time, but because I'm working with a binomial divisor, I could just kind of do 2 at a time. I mean, if you look over here, like this plus 5 I brought down, I really didn't use it until I brought it down a second time. So you could bring down each time or as you need the next piece. All right, then I divide the front. 14x cubed by 2x is 7x squared. And so I'm starting to look out here. It's not going to be it. 7x squared times 2x is 14x cubed. 7x squared times 7 is positive 49x squared, but then I change the signs. And that's the type of thing students forget. They forget to change the signs, or they only change the first sign and not the back, that type of stuff. 35 minus 49, that's going to be a negative, let's see, 5, another 9, negative 14x squared, and my next term to bring down is negative 37x. Another division, negative 14x squared divided by 2x is negative 7x. So that rules this one out. So distribute the negative 7 to negative 14x squared minus 49x. And then when I combine like terms here, change signs and combine like terms here, I see I'm going to end up with a, that cancels out there, negative 37, positive 49. That's 9, 10, 11, 12x, and bring down the 46 that's left over. 12x divided by 2x is plus 6, distributes to 12x plus 42. Then, when I change signs, I am left with a remainder of 4. What do I do with the remainder of 4? Well, notice the x cubed plus 7x squared minus 7x plus 6. This is all correct. This is all correct. But what's the difference here is the remainder of 4, the way I write the answer is I do what choice D has here. Sorry, scroll down a little bit. This is the whole quotient piece, and then it's, because this is a positive 4, plus that number over the divisor, plus 4 over 2x plus 7. Choice A has it as a minus, which would be the case if it came out to be a negative 4 remainder, but it's not. A positive 4 remainder means plus that. So plus remainder over divisor. That's what you do when you have a remainder. It's the quotient plus remainder over divisor. That's how we set up our answers. So there's just another example of long division for you. It's a long one. Sorry, it got kind of squished in the process. And so this is really just something that takes a lot of practice, a lot of being very careful along the way. But I do think, remember to divide, then distribute, then change the signs, then combine. It's when you try to skip steps and do too much at once that you tend to miss something along the way. We'll practice this a good amount in class. See ya. See ya.